Please open to page 207 in your student journal. In section 7.1, we're going to be adding and subtracting polynomials. But before we get to the actual adding and subtracting, we need to first of all figure out what the heck a polynomial is. On page 207, we get the definition of a polynomial. It says a polynomial is a monomial or a sum of monomials. Well, that definition didn't help me very much, unless we know what a monomial is. A monomial could be just a number, just a variable, or a product of numbers and variables. So some examples of monomials. A monomial could be something just as basic as the number 3. A monomial could be x to the second power. A monomial could also be negative 1/2 x, y to the third power. So again, could be just a number, could be a variable, or it could be a product. This would be a product where we multiply the numbers and variables together. So to create a polynomial, you can see a couple examples of polynomials down below. We take those monomials, those numbers, those variables, and we place addition signs or subtraction signs in between them. If a polynomial has only 2 terms, it's known as a binomial. Again, the terms are separated by the addition or subtraction signs. So if we have 3 terms, it's called a trinomial. The names are very fitting. The prefix bi means 2, so we have 2 terms. The prefix tri means 3, so we have 3 terms to our polynomial. A couple other aspects of polynomials. The leading coefficient. The leading coefficient is the very first number in our polynomial when the polynomial is written in standard form. So if we think of leader, the leader always comes first. So this means the first number, the first coefficient. Now I said it's the first number if our polynomial is in standard form. This polynomial is written in standard form. It means the terms are in order starting with the biggest exponent and ending with the smallest exponent. So the terms are in a special order according to exponent. We start with the highest one, which in this case is a 3. Then we go 2, 1, and then no exponent. The degree is our highest, or we could say biggest, or we could say largest exponent. So the degree is just a number. Whatever the biggest exponent is in your polynomial, that's your degree. And let me just make this note here. I didn't write the actual term for it. This was called standard form when we put the terms in order according to their exponents. So let's just take a look. Turn to page 208, please, in your student journal. And I just want to look at a couple examples where we have to put our polynomial in standard form, pick out the degree and pick out the leading coefficient, and then identify if it's a binomial or a trinomial. We look at number 9. I want to start with standard form.
The following teachers, please report.
Standard form means we need to write our terms in order, starting with the highest exponent and finishing with the smallest. So if I look at number 9, the x really does have an exponent of 1. So I have an exponent of 1, exponent of 2, and then our 5 at the end doesn't have one at all. So the highest exponent is a 2. So I'm going to start with 3x squared as my first term because it has the highest exponent. Next would come our x to the first power, followed by our 5. Again, standard form, highest exponent down to our lowest. The degree of a polynomial is its highest, biggest, largest, whatever word you'd like to use, exponent. In this case, my highest exponent is a 2. Our leading coefficient is the number that leads the whole thing. It's the number that's listed first. It's the number out front. The number out front is a 3. Lastly, we want to classify by how many terms we have. I have 1, 2, 3 terms. Again, the terms are separated by those addition and subtraction signs. So if we have 3 terms, prefix for 3 is tri. So we have a trinomial. Let's just look at one more of those before we move on to our adding and subtracting. With number 12, let's start with standard form, highest exponent to lowest. My highest exponent I see is a 4, so the first term I'm going to write is f to the 4th. My next highest exponent is a 2, so I'm going to put next f to the 2nd. My only term I have left has an f to the 1st. But now when I write that term though, I need to make sure that I bring that subtraction sign with it. The signs of your terms cannot change just because you're changing the order of those terms. Your degree on this one, the degree is a little bit tougher to see. The degree is the number at the beginning of the entire polynomial. I look and I have an f to the 4th. The number in front of that is really a 1. So my leading coefficient is going to be a 1. My degree is the highest exponent possible, and in this case it happens to be a 4. Last but not least, we need to classify. I have 1, 2, 3 terms. So we have another trinomial. Now that we've gotten a little bit more familiar with what a polynomial is, the idea of standard form, the degree, the leading coefficient, and how to classify, now let's dive into actually adding and subtracting our polynomials. Now when we add and subtract our polynomials, we're going to be using a concept that you all are already familiar with from your prior learning with solving equations and simplifying expressions. We're going to be combining like terms. And remember, like terms
Michelle Bowl.
Like terms means terms with the same variable and the same exponent. So let's take a look at number 13. In number 13, we're going to add these two polynomials. More specifically, these polynomials each have two terms. These polynomials would each be binomials. Now, when we add these, we can only combine the terms that have the same variable and the same exponent. So I'm going to start with my negative 4x and take a look at anything else I can combine with that 4x. I look in the next polynomial and I see I have a 6x. So both of these terms have the same variable, which is x, and the x has the same exponent, which in this case happens to be a 1. So these are two things I can add together. Those are like terms. Now I have a 9 and my 14. Oftentimes the mistakes come in when it comes to the correct sign when we're combining our like terms. So one thing I found has really helped students make less mistakes with this is to make any subtraction they see into plus a negative or adding the opposite. So now I can see that the 14 that I have is really a negative 14. Be very careful with your signs. When I combine these two, when I add them, I add the negative 4 and the 6, and then that variable just stays the same. It's just an x. 9 plus negative 14 is negative 5. Now I usually get the question, wait a minute, Miss Golly, so instead of having plus a negative 5, what if I have 2x minus 5? Those two, folks, are the exact same. And I don't care which way you write it. You write whichever makes most sense to you. What I would like you to do is just pause here right now and try question 15 on your own. In question 15,
Ms. Bowles,
I have x squared and a negative x squared. Those are like terms. I'm just going to group those together. 3x and 6x are like terms. I have a positive 5. And remember, this is a negative 4. So whether you want to add negative 4 or subtract 4, it does the same thing. Positive x squared plus negative x squared, that just gives me a 0. 3x plus 6x is just 9x. 5 plus negative 4 is 1. We don't need the 0 there, so 9x plus 1 would be perfect. Let's finish up with a little subtraction. Now subtraction, I'll be very honest, this is the area in this lesson that each year I typically see the most mistakes. To help limit our number of mistakes on this, take my advice from earlier. Any subtraction signs, turn them into plus a negative. My students that do this each year often make less mistakes with their signs on these questions. The idea of combining like terms is the same, but I have to remember I need to subtract everything from that second polynomial. So the easiest way I've found is to leave the first polynomial alone and distribute the negative. Or in other words, just change the signs for everything of that second polynomial. Just change the signs. That's all that negative does. That's all the subtracting does. Change the signs. Now we have an addition problem. G, negative 3g, And we have -4 plus 6. So we get -2g plus 2. Take a second here and pause. Try out question number 19. In question 19, again, make all of your subtraction into plus and negative. Every single subtraction you see, plus a negative, plus a negative. Leave your first polynomial alone. Do not change any of the signs, just write it as is. Change all of your signs of the second polynomial. So -3x squared becomes positive, -x becomes positive, -8 becomes positive. Now I have a pure addition question, and I can start combining my like terms. -x squared and 3x squared. -5 and +8. And then I just have a plain x on the end. -x, remember there's like a -1 there. -1 plus 3 will give me 2. And then it's just an x squared. The exponent doesn't change. Remember, we added those exponents when we were multiplying. But in this case, we're adding, so the exponent doesn't change. -5 and 8 plus 8 gives me 3. And we just have our x chilling out on the end. I cannot combine the x and the 2x squared because they have different exponents. One final thing, let's revisit that idea of standard form. Take a minute and make sure your answer to 19 is in standard form. To get standard form in question 19, we start with the 2x squared because the 2 is the highest exponent. Then we have x to the first power, and then our plain old 3 that doesn't have a variable with it at all. So when you are doing these questions for your practice and you're on your progress check, be in the habit of writing your final answer in standard form, highest exponent to lowest exponent. At this time, I'd like you to use your notes in your journal to complete your progress check. After you finish your progress check, please check it and let me know how you did.